It is 10:07 today, is that correct?
Yes.
And this is Chem 11:10, Chapter 3, Day 2. And our objective is going to be to be able to properly name any given ionic compound or ion. Now, good thing we're not waiting 5 minutes. Alrighty, now, we're going to wrap up Chapter 3 today. As I was going through it, I realized I taught all but like 1 or 2 topics yesterday or last time. What that's going to allow us to do, and just so I don't forget, is we're going to do Lab 3 after the test. Okay? UVA fall breaks next week. Did we all realize that? And if we don't, we'll have to take the test when we come back. Which I know that all of you say to yourself, oh man, I'm going to go and I'm going to study. And we all have deemed that that's a lie. Because you say you're going to study, but you never do. Right? Who agrees with me? Yeah, okay. So what we're going to do is I'm just going to put the lab off till after the break. And we'll take the test before the break. And I can assure you we'll all be better off. And what I did is I went through the test and realized that none of the questions directly related to the test are from the lab. So we'll just do the lab after. My other class can do it before because of how A-Day, B-Day works, but you guys won't. So what we'll do is we will review on Friday, and then we'll actually test on Tuesday. Okay? So then that way we get that out of the way. All right. So first thing you got to do is you got to get this sheet out. This is the polyatomic ion sheet. Okay? If you did not get one, you need to come and get one. Is there anybody not here the other day when I handed these out? Just yet? Everybody else has one? Okay. Alrighty. Now, the ones that I have marks on, you need to know. Okay? Now, in a perfect world, I would say memorize them. And to be honest, when I started teaching this class 5-6 years ago, I had my kids memorize these. And then I realized, yeah, that's stupid. So, the ones that have a dot by them, you need to know for the test. Okay, which means you'll probably just do what? Yeah, put them on your 3x5. I mean, that's usually what happens. Okay? So, you need to know nitrate, cyanide, carbonate, sulfate, phosphate, acetate, bicarbonate, and then the only positive one is ammonium.
Hi, teachers. Hey, can you send any students whose last names begin with the letters I to L to the small gym for retake? So letters I to L. Thank you.
Okay. We good there?
I understand.
Alrighty. Now, we need to know what a polyatomic ion is. Polyatomic. Anybody know what the term poly means? Many. Atomic. Atoms. And then I forgot, it's polyatomic ions. Ion means it has a charge. So this is literally many atoms with a charge. Now, what they're going to do is we're going to continue doing what we did last time. Going to play a lot of raisy handy gaming. But I got to remember there's 2 types of compounds, right? I got type 1 and then BIC. That's a C, not a G. BIC stands for what? Anybody know what this stands for? I wrote it down the other day, I'm sure of it. Binary ionic compounds. So there's type 1, and then the other one was type 2. Does anybody remember the difference between a type 1 or a type 2 binary ionic compound? Which one? The second one means it has more than one what? What were they called? Say louder. Oxidation states. Oxidation states. And how do you know that? How do you know that it probably has more than one oxidation state? Anybody remember? Nobody? Remembers how I believe I gave you like a 75% probability? What?
Is it with this?
Yeah, it is with that.
That's like 75% right here.
Oh, good job, Stratford. I'll give you that 3 seconds being late today. I saw that. Look, if it is one of those, it has a 75% likelihood that it's going to be a type 2. Now, the most obvious ones that are not are aluminum, zinc, and silver. They all only have one number. Okay? Now, what I will do, okay, I told you about the kids that used to fight over these seats. Every time we took this test, they'd fight over that so they could see that. Okay? I will give you the ones you need to know that have more than one oxidation state. Okay? Other than that, you don't have to worry about it. Just know that these are all ones. 1 positives. These are all 2 positives. If it is in here, 75% of them have more than one. Okay? Obvious ones that don't are aluminum, zinc, and silver. Okay? So, what they're going to do is they're going to give you something like this. Let's say I want to put sodium and nitrate together. Sodium and nitrate. Okay? Now, sodium is what? What is sodium? Nobody knows what sodium is? If it's high, you'll know. It's Na, right? So you had Na, but what is it when it's an ion? It is Na what? Isn't it Na positive? How do I know it's Na positive? It's in group 1. And didn't we say everything in group 1 was a 1 positive, right? Everything in group 2 is a 2 positive, right? Nitrate is what? No, nitrate. No, I know, but what is it? NO3 negative. The more you say it, the more you write it, the more likelihood you have of remembering it. Okay? So if I want to get these together, what are they going to give me? Nobody remembers that? Didn't we do this the other day? Now think about it. What do I do with these? What did I call it? Drop and swap, right? Well, they're each a what? 1. So I'm going to get just NaNO3. And that is literally sodium nitrate. That's its formula. That's its name. Yes?
Where does the NO come from?
I just gave it to you. Where are we talking about? Paul?
Yeah, okay, I get it.
That would have been, if it was just N, what would it have been? No. Nitride, right? Remember, whenever it's that negative, it ends in I did teach that last time, didn't I? Okay. I just get a bunch of people looking at me like, it's like he's speaking in German. That would be Wie heißt du? That's what is your name in German, by the way. Yes.
Okay, so we just switched the signs.
You just, well, because they were both ones, if they were numbers, I'd take the number. You remember now? Okay. Little refresher? Yeah. Okay. Now, so let's say I wanted to do this. Let's say I wanted to put iron and cyanide together. Iron and cyanide. Okay. So Baker. Okay. Well, first off, before I go to Baker, who can tell me anything about iron? Yo.
Isn't it going to be a type 2 because iron's in the transition?
Now, I don't know that it's going to be, but it has a what? A 75% chance that it is. You're right. Okay? Now, the reason I said let's go to Baker, because Baker's going to tell us the numbers it can be. Right? So, Baker, what are my numbers up there for iron?
2, 3, and 6.
Okay, now, 2, 3, and 6. If it's a 6 or a 7, or don't worry about them, just the low ones, right? So iron is going to be either Fe2 positive or it's going to be Fe3 positive, right? Now, cyanide. Does anybody know what cyanide is? It is CN negative, good job, but what is it? No, you don't know what it is? Anybody know what cyanide is?
Poison.
It's a poison. Yeah. Yeah, you guys aren't old enough to remember. Well, of course you don't. Some of your parents probably don't even remember. When I was a kid, well, let me preface this. Has anybody ever read a warning label on something and thought to themselves, who was that idiot that tried that? You know, it says, do not do this. And you're like, there's no way someone, but that's where those warning labels come from, right? Okay, well, every time I open a bottle of Tylenol or something, what's on the surface? Anybody know the first time you open a pill bottle? Isn't there that little foil tamper-proof seal on it? You know what I'm talking about? Do you know how they came to be? Okay, back in the late 70s, early 80s, there was a guy that would walk into a store and he would open, back then you could just open the box and open the bottle. And he was putting cyanide pills in there and killing people. Yeah, he killed like 20 people back east over a period of a few months. I mean, it gripped the country because nobody'd go in a store and buy anything anymore because they didn't dare. You know what I'm saying? And that's where tamper-proof seals came to be. They came out of necessity. Kind of interesting. I was young, but I remember it. Yeah, it was nuts for 5-6 months. I don't remember if they ever caught the guy or not, but yeah, he would put cyanide because it looked the same. Little white pills, he just put them in the bottle. Kind of crazy. So, how are these going to get together? What's my top one going to give me? FeCN2 like that.
Oh, Roman numeral.
Roman numeral. But the Roman numeral only comes in the name. Okay? Somebody look at that and tell me what it tells them. To me, this tells me that I've got one Fe, I've got one C, but I've got two Ns. If it's a polyatomic ion and I need more than one, it's got to go in parentheses. Okay? FeCN2. Now, what would its name be? Parrish, I can tell you're thinking about it.
Would it be like iron, Roman numeral 2, and then, I don't know, the cyanide, yeah.
Iron 2 cyanide. Just like that. What about the bottom one? What would its formula be? Nobody? Yeah, it'd be Fe parentheses CN 3 now, right? And how would its name change? Yeah, it'd simply be iron Roman numeral 3 inside parentheses cyanide, just like that. Okay? Now, let's say I wanted to do this. Let's say I want to put silver and carbonate together. Silver and carbonate. Let's do this. Let's actually just do this. Give me 5 hands. 5 hands for silver carbonate. Nobody? Need 5 hands. Just 5 hands. This tells me no one paid attention to what I said earlier. I have one. I said something earlier.
Is this the formula?
I want, yeah, we can start with the formula. That's half the battle. 2, 3, 4, 5. Okay, 1.
I got AG2CO3.
AG2CO3. Is she right? Why? What did you remember that most everybody didn't?
That AG is, it's not, it doesn't have multiple.
Exactly. AG only has 1 oxidation state. Now, a lot of times they're going to have to give you something to help you know that. You know what I'm saying? The fact, how did you know that it was a 1 to make it AG2? You kind of guessed. So it was AG positive and CO3 2 negative. I do my whole drop and swap, and that's going to give me AG2CO3. To name this, I'm going to give you, it's going to be silver carbonate. Just like that. No Roman numeral, because this is one of those exceptions. Yes?
Okay, but I do have a question. So AG, how do you know that it doesn't have like the 1 or the 2?
Okay, so that's what I'm saying. They're going to have to give you something. I will give you a very short list to write on your 3x5 so you know what they are. And I'm literally just going to look at the test and give you a bunch of them and say, know these 7. They're going to use some of them on the test. Most of the time, when they do that, you end up working backwards. Like they'll give you the name, so then I know, and then I can go to the formula. Because if not, you just don't know. You know, when I used to use this one, you had it in front of you all the time. You know, and if you're sitting right here, you can just look up there. But, you know, these two are screwed. Unless they bring their binoculars, which might not be a bad, you know, I don't know. So, does that make sense? Okay? Yes.
No, it doesn't need to be parentheses on the CO3.
Because it is one of those ones that I said when I mentioned, remember, it's in there, right? Which means it's got a 75% chance that it does. But it is one of those exceptions. Aluminum, zinc, and silver are the 3 most common ones that don't. Aluminum's a 3, zinc's a 2, silver's a 1. And these are just seem to be the ones they use the most. And I'd said that earlier today. I just, you know, was seeing if anybody was paying attention. Clearly, you all act like Mason, so whatever. Okay? And if you know him, you get that joke. I know Cal knows exactly what I'm talking about. Stratford.
So how do you like know if it's gonna be a 1?
You would have to work backwards. That's what I'm saying. They would either have to give you something to tell you that, or you would be able to work backwards from the name or the formula to know that. Because you're right. Other than that, you're just not going to know. Okay? So, let's do this one. Let's go with copper. I want to put copper, and I want to combine that with sulfate. And Sydney, why don't you tell me what my options for copper are? So I got a 2 positive and I got a 1 positive, right? They're my 2 options, a 2 positive and a 1 positive. I need you to combine that with sulfate, but I want the formulas. So I need 4 things from you. I want 2 formulas, I want 2 names. Okay, and I need 7 hands. 2 formulas, 2 names, both for copper and sulfate. 1. Two, 3, 4, 5, 6, 7. Alrighty. So, Dad,
Yo.
why don't you do the top one here? So sulfate is SO4 2 negative, right?
Yeah.
Right off the polyatomic. So why don't you give me the formula first?
Would it be CuSO4 because they cancel out?
Would it be? First time. I had 3 classes. Every one yesterday put 2s on them. Good job, Dad. Okay, what would its name be?
Copper, Roman numeral 2, sulfate.
Roman numeral 2 in parentheses,
Yeah,
sulfate. Were you 4?
That's 5.
You were 5. 4. Who was 3? Okay, Hannah, what do you got for the next one?
I have CuSO2.
SO2?
Yeah. Well, I have a question.
Yeah.
So the 4 on sulfate, does that reduce with
Nope.
iron?
That's actually going to lead me right into what we were going to talk about next, but that's a great point. Now watch. This can never change. Okay? And the reason that can't change is because the minute I change this, I change what it is. Okay? And that actually literally was the next thing I had written down is there's a thing you're going to learn, 8 verse 8. Okay? What that means is I had you learn all the 8s. So like right now we're working with sulfate. Sulfate is SO4 2 negative, right? Then we have sulfite with SO3 2. Did my mouse said a 3?
Yeah.
Okay, I'm just checking. Mind of its own. SO3 2 negative. This is sulfite. Okay? If it was SO2, I don't remember what it is. But it's not sulfate anymore. Okay, the only thing I can change is those other subscripts. That has to be a 4 no matter what, or I'm not working with sulfate anymore. Yo.
Hey,
Hey.
any chance you've got a minute to come down for IEP? For hobby?
I was going to ask if that's who that was for.
He's got some troubles getting here.
I know, we talked about it last night.
Oh, you did talk.
Yeah, I mean, my fear is he goes online. I mean, it's never happened. I've never had a kid do it, ever. And I told him that
For
last
sure
night.
he won't.
Yeah. So what do we? I can't though, because we test next week.
Okay, but if you've talked to him. then-
Yeah, I talked to him. I just told him my opinion.
So you're gonna keep him
I would. I told him he needed to stay. He's too close not to.
at 3:30? Is that?
I'll have to. I'll talk to his teachers, but he's got to commit to 3:30, no later.
That's my fear. Is that
Yeah.
then it becomes 4.
Yeah, exactly. I know. That's
Then
what I'm saying.
3:30.
Yeah,
Okay.
that's the very latest.
Thanks, man.
Okay. Remind me to make a phone call when I'm done. Yeah. So yeah, it's got to stay SO4, or it's something different. Does that make sense?
Yeah.
And so what I would do, and this is important, is just to understand that you've written down all the 8s, carbonate, nitrate, whatever, right? The minute they use an ite, all I do is remove a what? How do I go from 8 to ite?
Take away an O.
I take away an O. The charge, nothing changes. So sulfate is SO4 2 negative. Sulfite is SO3 2 negative. Okay? Now, back to this one. So I got copper and I got sulfate. What would have to happen here? Because this is SO4 2 negative still, right? What would I have to have right here? Wouldn't that have to be a 2? My whole drop and swap, right? Now, because I only need one of each of these, I don't need any what? No parentheses there, right? And what would this one be called? Copper. No matter what, I've still got to have the 1. It's still got to be copper 1 sulfate. This is the one time where you've got to put that Roman numeral because that tells you the charge on that atom, or on that ion, yes.
So why don't you like do the drop and swap thing with the 1 and put it with the 4?
Because remember, that would look like this with the 1 there. It's not needed.
Okay.
Does that make sense? Because this is a group of atoms, right? And when I have multiples, I've got multiples of that group of atoms. Not multiples of just that atom. It's that group. So that's why I've got to have parentheses. Do we understand the difference there? I've got to treat them as a group. Okay? Let's do some more. Let's do chromium and acetate. So I got chromium and acetate. Okay? So, who else is over there? Damn it. Fisher. Give me your name again. Corbin. What's your last name, Corbin? Geddes. Geddes, right? I knew how to spell it. Why don't you give us our options for chromium? What my numbers are going to be for chromium. 6, 1, and 2? 6, 3, and 2. Well, what do we know about the 6? 6 doesn't count, so I'm going to be a chromium 3 positive, and I'm going to be a chromium 2 positive. Now, acetate, pay attention. When we write it like this, we'll use this top way of writing acetate. C2H3O2 negative. The next way is called Chiku. See how I get Chiku out of that? Okay, that's the way it bonds. That's for down the road. Okay, for right now, we'll use this top version, C2H3O2 negative. Okay? So I'm going to put chromium and acetate together. And let's go for 8 hands. I want both formulas and both names for those two. And I need 8 hands. One, two, 3, 4, 5, 3 more, 6, 7, 8. Alrighty. Lexa, what do you got for the top one I have written down here? What's my formula?
CR, and then parentheses, C2H3O2, parentheses 2.
2? Did you do the 3 positive on top or the 2 positive on top?
I did 2 positive.
Okay, so that one would be the bottom one. This one's going to be a 3, right? Okay, and what's the name for it?
Chromium 3 acetate.
Chromium, Roman numeral 3 in parentheses, acetate. Is she right?
Yeah.
Yes, she is. How about, who was 7? Oh, who was 8? What do you got for me, Criddle?
So CR and then in parentheses C2H3O2 and then a 2.
And it's going to be
Chromium 2 acetate.
Roman numeral 2 in parentheses, acetate. Is this making any sense yet? I mean, the only thing that changed from the other day is this second thing, right? It's now a polyatomic ion. Okay? Now, I forgot today was a short day, so I'm going to skip. We were going to do one more, but I'm going to skip it. But we do need to cover size as it applies to ions. What that means is this. If I gave you calcium versus calcium 2 positive, or I gave you chlorine versus the chloride ion. Okay, now, if I want to talk about which is bigger between calcium or the calcium 2 positive ion, anybody want to take a guess? Which one's bigger? Is it calcium? Anybody agree with Stratford? Think it's calcium? Yeah? Why do you say that?
Because if you two positive, you're taking them away, so it's like making it smaller.
Exactly, because it's the whole hotel analogy, right? Calcium has 4 floors in it. Calcium 2 positive only has 3 floors in it because those electrons are gone, right? Which means calcium is going to be bigger. What about the anions? What?
The CL negative.
Cl negative is bigger because it's like the size and ionization energy. Remember how they were opposites of each other? Same thing works here. Positive ions are smaller than their element. Negative ions are bigger than their element. Okay, because I'm adding an extra electron, they're going to be farther apart, they're going to get bigger. Losing electrons, I'm going to get smaller. Okay, there's probably a reason I'm using this specific example. Did you catch the? Okay, just checking. Long creepy wink. Okay, not necessarily those elements, but that kind of example. Okay, now just so you understand, we're going to review on Friday, which means you probably need to have what? Homework done. Okay, I realize it's one of those things that I'm planning this out, and I'm like, we'll be all right if we take the test after fall break. And then I'm like, yeah, no, we won't. No, we won't. We won't. Because I know things. I got 23 years of knowing things, right? And I know that every time my students say, oh, yeah, we're going to study. And they come back and go, shit. And I'm like, exactly. So we're just going to do what we got to do. So we'll review on Friday. And that means we will test on Tuesday. I don't know what that date is. Anybody know what next Tuesday is? 13th? 10/13. And then we will do lab 3 when we come back. Now, the only problem with that is that we're going to lab the day we come back. So you'll have to have that pre-lab done. So I'll remind you on Tuesday that we're going to do the lab when we come back. Then I'll try to remember to send you an email or make an announcement over Canvas, like Friday night or Saturday night or Sunday at 11:59. Hey, we're doing the lab in the morning. Well, I figured I should wait because you all wait. I saw that look on your face, Sydney. Even behind that mask, you look, well, that's awful late. I'm like, well, I'm like being like you. Okay? So, yeah. Okay? When we come back. And I think that will be way better off than if we wait to take the test. And if you don't agree with me, you'll be proved wrong. Because I'm smarter than you are. Because I'm the teacher. Not necessarily more mature, but I am smarter. Okay? Questions? Do we think,
what polyethylene ions should you know?
You didn't write them down?
I don't think I got them all.
All right, there's 8 of them. Okay? They are nitrate, cyanide, carbonate, sulfate, phosphate, acetate. The very bottom one is the only positive one. It's called ammonium. And then the only one on the right is bicarbonate. Okay? And I'm going to be honest, it's a situation, they are the most commonly used polyatomic ions in the world, which is why I do that. I used to have my students memorize them all. And, yeah, that was stupid on my part. These are the ones you're going to see over and over and over again. Did we talk in here about Beirut, Lebanon? The explosion they had over there, right? Well, that was due to one of these. Yeah. Ammonium nitrate. Ammonium and nitrate. That's what caused that explosion. That's the. Have you ever noticed in the spring the little white babies that are all over the sidewalk? That's from them fertilizing. That fertilizer is that. And it goes bada boom, really big boom. You ate them? That I was gonna say that would be bad. Yeah, I saw you doing it. That would be bad, like really bad. Yeah. Okay. Questions? Yo.
I don't know, 11, 6, 9.
So when we're talking ionic bonding, okay, you're never going to gain 6 or lose 6 electrons. You're going to gain 2 is much more likely. Or lose 2. You know what I'm saying? When we get into what's called redox reactions, which is a little later down the road, then that number will come into play. But for now, we don't need to cloud our mind with that stuff. Worry about the 2 smallest. They're the ones you're going to see. Okay? And a lot of times they'll actually have you calculate that by going backwards. You know, so what they'll do is they'll give you something like, let me look really quick. They'll give you something like, here's a good one. Let's say I gave you, manganese to nitrate. They'll give you something like that, and they'll say, what is the charge on the cation? Well, it's easy. That had to start with Mn2 positive. You know what I'm saying? They'll have you be able to figure that out another way. Because if not, you just wouldn't know. Which is why I've always wondered why they don't let us use this periodic table. But I'm not the boss. Yet. So, one day maybe. Okay? Good question. Anybody else? Okay, time is yours. Remember, it is a Wednesday. It's that every other Wednesday, so we do get out early. I did not know that until my last class pointed that out. So, I don't know how much time we have left. Do we have any of those people in here? Oh, yeah, thank you. Okay, let's get going.